Well, hello everyone. I'd like to welcome you today to this afternoon's Orion Stationary Recovery Test. I'm Rachel Kraft, Affairs Officer with NASA. I'd like to welcome our three speakers today. They've each played a critical role in developing recovery operations for Exploration Flight Test 1, which is NASA's mission and first mission that will happen next year in September of 2014. Wilson. Scott is NASA's Manager of Offline Processing, which includes landing and recovery operations. Navy Commander Brett Moyes, Future Plans for the U.S. Fleet Forces. And Jim Hamblin, Landing and Recovery Operations Manager for NASA's Ground Systems and Development Operations Program. The test is a bit dynamic, so Jim is actually going to take a few questions during his part of the narration that's going to happen. So feel free, Jim talks, to get up. We have a mic at the back, and ask questions if you feel the need. With that, Scott, would you like to start us off?
Hey, good afternoon, everybody, and thank you for taking time to come out and join us for the first test of the Orion program. Today, I wanted to give you a little bit of background on the overall the exploration efforts that we have underway that'll kind of put this test in context for you. As many of you know, NASA has two main efforts right now going on in human spaceflight. We've got a commercial crew and cargo effort that's really focused at low Earth orbit operations, and we've got an exploration focus which is looking at more of those deep space exploration, really leaving orbit and exploring the Moon, Mars, and asteroids and beyond. So. In low Earth orbit, we're continuing to live and work on the International Space Station, where together with our international partners, we've been maintaining a continuous human presence for almost 13 years now. We're working closely with our commercial partners and commercial companies to help them develop the capabilities to provide routine crew and cargo in low Earth orbit that we've done historically with. This does two things. It really helps us spawn a commercial market for commercial space activities, but it also helps free up NASA focus more on the exploration activities in the deep space exploration. And in that exploration area, we're beginning to build the vehicles and the systems necessary to carry humans beyond low Earth. And we're executing that through three main programs that you probably have heard of. The Orion program is developing the crew module, the service module for the helicopter here, and the launch aboard system that really comprises the Orion. And Orion really is all about providing the habitat for the crew, where the crew will live and work and control the spacecraft while they're in space doing exploration. And that program's led out of the Johnson Space Center in Houston. The Space Launch Systems Program, or SLS, is led out of Marshall Space Flight Center, primarily working to develop the heavy lift rocket that'll launch the Orion and other heavy payloads in orbit for us. And the Ground Systems Development and Operations Program, which is tasked with essentially integrating the spacecraft, the launch vehicle, servicing it, launching it, and doing the operations that we're here to talk about today. As we develop the exploration capability, we need a robust test program to build a little, test a little as we go. We've made great progress on that already. In 2010, we built what we called the pad abort demonstrator. It was a Orion capsule that tested ability of a launch abort system to really pull the crew and the capsule away in the event of an emergency. And that was a test at White Sands, New Mexico, really to test the stage of pulling the crew away if you had an emergency at the launch pad. In 2011, we continued. We built the next capsule. It was called the Ground Test Article. And that was really to build the first crew module structure, and we put that through a series of environmental tests to make sure that we really understood the design of the vehicle and used to help influence what we're doing on the current mission, which is Exploration Flight Test 1, which is we're here to talk about today too. Last year, in July of last year, we finished completing the structure for the main crew module for Flight Test 1, and we delivered that from the Michoud Assembly Facility in New Orleans Space Center, where it's in final assembly today, being readied for a launch in September of 2014. In 2017, we plan to fly what we call Mission 1, or EM1, and that's really the first time that we'll put together the Orion crew module, service module, launch abort system with the SLS rocket, and we'll crewed mission to basically wring out that whole system and make sure we understand it before we do human flight with it. And in the 2021 timeframe, we'll actually fly Exploration Mission 2, which is a full-up crewed vehicle of the SLS. So I'd like to come back for a minute back to Exploration Flight Test 1 and talk about that a little bit more. So as I mentioned earlier, the spacecraft's in final assembly today. It'll launch in September of 2014 on a Delta IV Heavy rocket out of Cape Canaveral, Florida. The mission will take it up for two orbits around the Earth. They'll be very high orbits going up to about 3,000 miles, about 3,600 miles above the planet, and that's the furthest that we've traveled with a human-rated spacecraft or a human-capable spacecraft really since the Apollo days. Shuttle, it was a great program, but we really were limited to low Earth orbit. So for the first time, we're really reaching the distance we leave from the planet, and it's important for a couple of reasons. Obviously, in exploration, farther, but for this particular flight test, it allows us to come back at re-entry speeds that are close to what we'd see when you come back from either the moon or an asteroid mission or Mars. And it's very important because one of our test objectives we've got here is to really understand the thermal systems. And the vehicle, while it looks like a capsule, and a lot of people say, hey, that looks Apollo capsule, it's actually much bigger and much more capable than that. And when you take a large vehicle that comes in at those kind of speeds, which is much higher than we've ever seen for shuttle reentries, there's a lot more heat. One of our big test objectives we're trying to learn with the flight. We come back in, we begin that reentry at about, it's about 20,000 miles an hour coming in over the Pacific. We deploy parachutes at that point once we get down through the atmosphere, separate a forward. Jim Hamlin will talk a little more about that with recovery ops later. And we basically about 550 miles south of San Diego off the coast of Mexico. And when we do, obviously we need to cover the vehicle. For Flight Test 1, again, it's an uncrewed mission, so we need to be able to recover the capsule, the parachutes, and that forward bay cover so that we can understand how it performed in flight. For later crewed missions, obviously it's important to recover the and be able to retrieve the crew and bring them back safely as well. So today is the testing those recovery methods, and we have what we've kind of referred to as a crawl strategy for doing that. We began crawling really with what we called port tests, Naval, and diver training and simulation in the neutral buoyancy laboratories at the Johnson Space Center. In partnership with DoD, we're now taking the first steps in learning the water to safely learn how to recover the crew module in open water, and we're doing it here in the safety of the port. Later in the year, or at the beginning of the year, we'll do more of an open water test, which we test, and we'll do that off the coast of San Diego. And so the testing today here at DoD really continues a long history of cooperation that we've had between NASA and DoD that really spans the beginnings of the space program. It really started with the Mercury, Gemini, and Apollo programs in terms of capsule recovery, and continued through shuttle in terms of search and rescue activities and support for our launches and landings. The last U.S. splashdown of a capsule occurred in July of 1975, which was the Apollo-Soyuz capsule that landed. And the test we're seeing today is really the first time that we've worked together with DoD to recover a capsule really since that mission. So it's a historic start to the new program that we're doing. So really kind of in closing, on behalf of NASA, I just wanted to say thank you and express our sincere appreciation to the Department of Defense, to the Air Force, and to Captain Nelson and the crew of the Arlington on their support and their hospitality as we've been here today. So with that, I'd like to turn it over to Navy Commander Brett Moyes with U.S. Fleet Forces Command.
Good afternoon. Can you hear me all right back there? As Scott said, I want to say thanks for being here and participating in today's events. Today marks a significant milestone in the Navy's partnership with NASA and the Orion human spaceflight program. The Navy is excited to support NASA's continuing mission of space exploration. Our unique capabilities make us an ideal partner for NASA in the recovery of our astronauts in the 21st century, just as we did nearly a half century ago in support of America's quest to put a man on the moon. For the past 20 months, U.S. Fleet Forces Command has worked closely with NASA, preparing for the stationary recovery test that you'll see here today. The test involves Navy sailors, civilians, contractors, the USS Arlington, Seabees, divers, and numerous other Navy organizations. The procedures used to recover the Orion crew module that you'll see are very similar to the procedures used for recovering a disabled landing craft. Numerous smaller-scale Orion crew module recovery tests have already been conducted, but this is the first full-scale test using a Navy ship. We are performing this test in the protected environment of Naval Station Norfolk, with future tests to occur in the open ocean, as Scott alluded to, off the California. This systematic approach allows us to more fully assess our personnel, equipment, and procedures in a progressively more challenging environment, so we can ensure we receive maximum benefit from each test and minimize the overall risk to our personnel involved in the testing. We are happy to host this essential landing in our Hampton Roads community. With that, I complete my statement. I look forward to answering any of your questions during the demonstration, and I'm going to turn the mic over to Mr. Jim Hamlin. Mr. Hamlin is the Landing and Recovery Manager for the Ground Systems Operations and Development Program at the Kennedy Space Center. Thank you.
Well, good afternoon. The Landing Recovery team is here this week to conduct testing of an Orion crew module mock-up that we call a boilerplate test article, and that article out there that's the white in color. We're conducting initial testing of the BT while the Navy ship is stationary, and this allows us to practice our procedures in a benign environment with no ship movement and minimal wave action. The well deck method of recovering Orion crew module, or CM, was first envisioned about 7 years ago. NASA asked the Department of Defense if any of their ships would be suitable to recover Orion. Although never having been used for this purpose, the amphibious assault ship, or well deck ship, quickly became the preferred option. The most significant benefit with the method is that it allows the flight crew to maintain inside the CM during recovery. And the CM is considered recovered when it's secured inside the well deck, the water is drained from the well deck, the crew egress stand is put in place, and the side hatch is opened. So you can imagine if we were a few miles from the site, it's going to take a while to make all this happen. And just to drain the well deck, for instance, could take 30 to 45 minutes. NASA's tasked the entire recovery from splashdown to side hatch open within 2 hours. The reason for the 2-hour time period is to keep the flight crew from becoming overheated after cooling is turned off. The Navy has 3 classes of well deck ships to accomplish the Orion recovery mission. The ship in front of us belongs to the LPD, which is the most suitable well deck ship for our mission due to its overall capabilities. This particular ship is the USS Arlington, known as LPD-24, and it was commissioned only in April this year. It's very new. The 3 classes of amphibious assault ships have a uniform well deck configuration. The width is exactly the same, approximately 50 feet. These ships are designed, as was to cover the LCAC vehicles, and those vehicles are just under 50 feet wide, fit snugly within the well deck. And the LPD here can carry 2 LCACs. It's taken a significant from NASA, Department of Defense, Lockheed Martin, and other contractor organizations to bring where we are today. During the 7 years since the well deck method was conceived, side by side to develop the procedures that will result in a safe and efficient Orion recovery. One early concern was whether or not the CM or the well deck would be damaged in the recovery process. The key to mitigating this possibility was controlling the of the CM during its transition inside the well deck. Today, CMs are obviously very calm, and this is by design so we can prove our methods first in conditions that prove minimal risk. Our primary means of mitigating the risk of damage is using a series of tending lines to keep the CM lined up in the center of the deck. While the CM is outside the well deck, tending lines are handed by in 2 7-meter boats. When the CM is inside the well, tending lines are handed by personnel in the wing walls high above the well deck. Two Zodiac boats, the smallest of the boats you'll see there, are used initially to connect the boat lines to the CM, and later you'll see them connecting the lines from the wing walls as the CM transitions over the stern gate. Once the CM is past the stern gate, the gate will be lifted 45 degrees. I think today for this demonstration they're going to leave it down so we can continue to see it. What that will do is will allow the water inside the well deck to calm down regardless of the conditions outside the ship. And that enables the CM to transition into the recovery cradle waters. A winch line is attached to the CM, and that will actually begin our demo in a few minutes. That will pull it into the cradle located about 20 past the stern gate. Our test team is focused on specific objectives this week. First priority is, of course, proving that our basic concept for recovering the Orion C sound. We will run through a short recovery demonstration. It will take about 20 minutes, I estimate. Although the CM with flight crew inside is the most important item that we'll recover, it's not the only thing. We're also tasked with recovering the three main parachutes, a forward bay cover that is jettisoned prior to main parachute deployment, and 5 other parachutes on a best effort basis. This week we are testing recovery of the forward bay cover, which will be brought up using a knuckle boom crane on the port side of the ship, on the left side of the ship as you see it here. And that was successfully done this afternoon, or this morning rather. Parachute recovery is not an objective this week because the water is not deep enough here. After the stationary recovery test, we'll gather lessons learned to prepare for the next step in our testing. Lessons learned may lead to a change of procedure or hardware design. And we have just over 5 months to make ready for the underway recovery test in January 2014, which will occur on the West Coast near San Diego. The Navy has scheduled another LPD for that test, the USS San Diego. It's LPD 22, and it's also a new ship. It was commissioned in 2012. The underway test is a 4-day test at sea, unlike this is stationary at the pier. We plan to test CM recovery in up to 6-foot wave height, which is the recommended maximum sea conditions for nominal recovery. Then we'll practice recovering all 8 parachutes and the forward bay cover in the open ocean. After the underway test, we'll again gather lessons learned and make ready for the first actual mission, which is Exploration Flight Test 1 in September 2014. I'd like to personally thank all the landing and recovery team members from the Department of Defense, NASA, Lockheed Martin, and other contractors who played a role in the planning effort that made this possible today. Thank you for your strong support, dedication, attention to detail on safety. And at this time, I think we're ready to take some questions, give some answers, and in about 20 minutes, we'll start the demo. Questions? Yes? Oh, we have a mic, I guess, over here.
So everybody can hear you.
Great. Could you tell me a little bit about why this is advantageous to use one of these ships as opposed to an aircraft carrier and use a helicopter to lift people up onto the flight deck?
Well, the flight crew desires to remain inside the capsule during the recovery. And they also don't want to be live lifted with a crane with them inside. So this seems to be the best method of all, where they are able to stay inside. Hopefully the sea conditions aren't so energetic that it's making them sick inside the capsule. If it does, we have a procedure where we'll install a stabilization collar like we did during Apollo. And instead of bringing a helicopter in, we'd probably just bring a boat, and we could drive them right up into the well deck outside the capsule. But the crew is actually really excited about doing the well deck recovery. It seems to give them the best options all around. Next question? Yes. And could you go to the mic back there, please?
How many of these recovery ships do you have, and are there any other like it that you would consider? Thanks.
We have several ships of this class on both the East Coast and the West Coast, so it's we're ideally suited to be able to do those operations on either coast. Here you're seeing the USS Arlington on the West Coast. As we mentioned, we're going to be using the USS as part of the underway recovery test, and then the third of the series of tests will be where we actually put the crew module into space, and it'll be recovered. That'll also be the USS San Diego as of right now.
It seems to me that the process is kind of bottlenecked by the time limit of 2 hours before the astronauts overheat. Wouldn't it be easier to give yourself more time in case something happens, something unforeseen? I mean, or is that 2 hours a hard time limit that can't be circumvented? I mean, it seems like a safety.
Well, the 2 hours is really based on when they turn off the suit cooling. They have 2 hours that they could leave their cooling before they have to turn it off. So theoretically, they would have those 2 hours plus maybe an hour and a half after that, which is equivalent to what they're normally. But again, if there's a problem and they have to get out of the capsule, there is a way we can do that. So obviously, we're not going to leave them in the capsule. Cook. I think 100.5 is the core body temperature that we want to keep them below. And testing in warm environments has shown that after about a 2 hour period, that's when they hit that level. Any other questions? Yes.
And would this thing only land, or you have situations in which you can bring it down in other places?
Nominally, it only lands in the Pacific, and that's just the physics of the flight. We considered possibility of it landing in the Atlantic, in the Gulf of Mexico, but there were issues of overflying land. And there's a service module that has to be disposed of behind the capsule. So I think you're always going to see it landing in the Pacific. We talked about the EFT-1 flight being 550 miles south of San Diego. Well, the other missions, EM-1, EM-2, and beyond, those will be actually closer to San Diego. They won't be way south like EFT-1. So I'd expect San Diego is the prime base of operation because it's close to there, and that's where all the Navy ships are that we need.
Let me just add to that too. So Jim mentioned the nominal landing is water landing. However, we have design features in for attenuation on the crew seats and things in the event it off nominally on land in a lot of cases. So we're trying to help protect the crew in those cases as well. So. Okay, are there any other questions? Okay, I was asked here just to talk a little bit about some of the upcoming milestones, and I talked about the progression of the Exploration Flight Test 1 in September 2014, the uncrewed mission in 2017, and the 2021 full-up crewed mission. On the EFT-1 vehicle, I mentioned it's in assembly today at Kennedy Space Center. It's nearing a point where we're putting in propulsion tubes and propulsion systems and environmental life support, environmental control system tubing. We're about to enter a phase where we start putting in avionics, and we're putting in all the harnesses, and our next big milestone is really the power-up. It'll be the first time we power up the spacecraft, and that'll be in the late fall. We'll get through assembly in the spring. We'll send it in the summertime, roughly, to go in and do servicing. And by servicing, we mean the fueling operations, the ammonia loading operations, and those sort of things. And we'll send it out for integration with the launch abort system, which I mentioned is the little solid rocket motor that sits on the front for crew escape. And once that spacecraft's integrated in the late summer, out to Cape Canaveral Air Force Station, where we'll integrate it with the Delta IV Heavy. So that's really kind of the progression of where we're at today. See, Jim, did you want to add any other comments or anything from a perspective?
Hi, my name's Andy Kewitt. I work for Detachment 3. We're the DoD liaison. We work all human space flight support, coordination with Kennedy Space Center, Johnson Space Center, and we work with DoD to figure out how we can work with NASA to get the things done, rescue the astronauts ultimately. So I've been working this mission for the last years, active duty in uniform as a Navy commander and now retired as a civilian. What I can tell you about here is what you saw a little bit ago, 1 o'clock or so, was actually the vehicle landing. Navy on time, ready, we're out here ready to go, basically waiting for you all and for the speeches to happen. So what happened was after it lands, our Navy divers, who are in the Zodiac boats, like Jim said, the smaller combat rubber raiding craft, or F-470s, you get a different name for the same boat, essentially. We have our Navy divers. We've trained them at the lab in Houston of how to have hands on the vehicle, the hazards of the vehicle, the attach points, the equipment, the procedures. Out of the group, they're the personnel that have been trained in advance, and that's the plan. The rest of the ship, we're expecting, we'll have it assigned in advance, but if for some reason the Navy needs to change our ship at the last moment, just-in-time training for the ship and the crew. But the divers are part of our team that are going to get trained in advance. So after it lands, it has hazards on board and things like that. The divers will be in their full dive gear. They'll approach the vehicle. They'll have some testing equipment, and they'll determine whether there are any hazardous commodities present and whether it's safe to approach. As they come upon it, they're going to come from upwind, and they're going to do a circle around the vehicle. When they come to the zero point, which is in the center under the windows, that's also the cold side of the vehicle when it comes to entry. Cold being relative terms, the hot side through entry much hotter than the cold side. They're going to attach a sea anchor. Sea anchor looks like a parachute in the water. It's going to tickle down and it's going to keep it from spinning, which is going to enable them to do the rest of their mission. So what else do they need to do? EFT-1 is an experimental flight test. We have a lot of engineering analysis that NASA is asking us to accomplish so we know we can do things safely and we know how the vehicle performs. Like they said, the heat shield is important, so we don't want to damage the heat shield and we want to know what that looks like. So one of the things we're going to do is the divers are going to have some cameras and they're going to do a slow 360 drive around the vehicle, taking video and still imagery. When they complete that, they're going to take it back to the big boat, the 11-meter rib, where the photographer is trained to look at that imagery and make sure that we got good imagery for the mission. When he's taking that back, our other boat's actually going to have a Navy dive gear that is going to go in the water, and he's going to take imagery of the heat shield. Sea anchor is keeping it stable. He's got a boat next to him performing, and he's going to do a 360 and a crisscross pattern underneath, imaging the bottom of the vehicle, imaging the heat shield. We've tested it in the neutral buoyancy lab, and we're going to test it out during the underway recovery test to make sure the camera equipment that we have is going to meet our mission needs. Water 550 miles south of San Diego is actually beautiful, so we're anticipating some nice, unlike in the port. So when that happens, they'll take that video imagery back and make sure that we're meeting the needs of NASA with the engineering video. So the next step is to actually hook up our tending lines, pass them to our boats, and the ship won't be stationary. The ship will be doing their approach to come in. While all that's happening, we have a couple other small boats that are going to be doing parachute capture. Essentially, we're going to get the chute and put a flotation on it to mark it, and we're going to leave it there to come back and get it later. We're going to be doing the forward bay cover recovery if it's still floating. And essentially, we'll put some rigging on that with some flotation to keep that floating. Our primary concern is always the crew module. The ship will be making their approach, and they'll come alongside. That's about where we are right now in the timeline. And so you're going to see us artificially here in a couple of minutes, tow the vehicle to be behind the ship. Now, we've modeled this after an emergency LCAC landing craft air cushion vehicle. They're a hovercraft. When they lose their ability to be a hovercraft, they're like a big barge. Our ship has to come to them. We need lines to that vessel, tow lines, and it's a pretty big tow line for an LCAC. So it's small lines that they pull through, and they get bigger lines until they get, which is about a 1-inch thick steel cable. The Navy has always offered that up. Hey, we have a winch on board. Do you want to use ours? It's a little too much capacity for us, so NASA has brought their own winch with a, I think it's a 5/8-inch floating line cable that more than meets our needs to recover Orion. So as they work it into position here behind, the next step we're going to see, which we're still about 7, so I should talk a little bit slower. The next thing you're going to see is they'll get in position behind the boat, but really the ship is pulling alongside and tossing lines to the divers, and it's that winch line that's going to come out and get hooked up. The one thing with that sea anchor, which we don't have on here either, we want to into the seas to minimize our seas. We want to head into the seas. That sea anchor is to line the vehicle up with our tow line into the seas. We did some testing off Port Canaveral that Scott mentioned with our port capsule, and that wind had Orion moving about 2.5 knots. So it's under sail when it's out there. So it'll move pretty good. One of my coworkers is an Air Force man. He's kind of old as dirt. He actually did Apollo training and remembers jumping on Apollo, and they didn't have boats with motors, and they had to jump ahead of where Apollo was moving and catch it on the way by. So we're jumping, or putting our guys in with boats that they can actually go out and maneuver, and they don't have to chase, because there were a couple occasions where the swimmers had to actually chase down Apollo to catch. So they'll be passing those the winch line. They'll get it lined up. One of the things that you'll see here that it's in the basin, it's in the port. Normally the ship will be towing the capsule. We'll have good control over it. It's going to stay where we want it to stay at that length of the winch line. Here you'll see it tend to creep into the ship depending on how much pull we get from our 2 7-meter ribs. Really, they're going to be kind of anchors. We're going to remove that sea anchor. They're going to kind of anchor themselves to keep our crew module lined up, to keep Orion or our BTA lined up. It wants to walk off. We actually did some tow testing with a quarter scale model at Naval Surface Warfare Center, Carteret, and it'll walk rudder on the bottom of this vehicle, and it has a mind of its own. So those 2 7-meter ribs with the tending lines are designed just to keep it lined up. The next is the divers will come in approaching the ship, and they're going to get wing wall tending lines. We're using 2 tending lines from each side of the wing wall. Same kind of setup that they would do for an emergency LCAC recovery. Navy sailors in the wing walls, lines to help tend the vessel into the vehicle. Same thing they're trained to do. You see the flag on the right side of the well deck. That means we have a green well for recovery. You also see the wind, the vehicle to the port side right now. Next thing is the divers going in to pick up the winch line. So I think we have a minute here, and I'll pause and see if we have any questions, since we had a lull before in questions. Anybody have any questions about the procedure you're doing?
You did some practice in the last couple of days. Did you learn anything or make any tweaks?
We've learned a lot. A lot of the things we learned are that when you're stuck or a basin like this, the wind and the current can really affect you, and we don't anticipate that's going to happen, or it won't be an issue out at sea. We've learned better with the Navy ship. It's the first time where we're actually working with the ship and the crew. Command and control is going to be essential, and how that coordination works. But one of the big parts of our test is, does our hardware work and do our procedures work? And we've been very successful with that. So,
Scott, question question. Just tell us again how close in dimension and weight this is to the EFT-1 capsule.
So this is an accurate simulation. It's obviously not the capsule we're going to fly, but it's an accurate simulation of both the outer mold line shape, weight, and CG of it. So this is very representative of what we'll see.
Question about splashdown. If there's a stable tube splashdown, what's your modifications?
If there is a stable tube, there's a nominal system that should be working. The CMIS bags, the crew module uprighting system. You see the 5 bags on top of the capsule. Those will slowly inflate and will cause the capsule to upright. And the possibility of even one of those bags malfunctioning, much less 2, is very remote. And with the bag malfunctioning, it'll still upright. So we are developing a procedure that if it just is a really, really bad day and multiple fail, we should be able to get the capsule uprighted. And do that is probably one of the divers would go underneath the capsule and attach another bag and inflate it. We're still developing that.
And that's actually something that falls right under the purview of the mud suit divers that we're using. They do salvage operations. They said, oh, you want us to use float bags? Okay, we can do that. So that is. So while we were talking, they've connected the winch line. Now the winch runs through our cradle, and you'll be able to see that when we go on board. And we have a fair lead in the cradle. So the winch line is all the way forward up a deck from the well deck. The ramp. So that's quite a long ways through the well deck, but it goes through a fair lead. Lead is 2 parallel beams with a top on it, so it runs through there. So it's a guiding factor to pull it into our cradle. So it's going to help guide it into the cradle also, and then our 2 7-meter ribs will be guiding it. So normally we probably would be so far off. Our expert Navy ship drivers are going to get us pulled alongside and get in front of us into the seas. One of the things with the ship in front, the seas are going to come a little bit behind. That's going to help us work and handle the crew module.
Okay, 1 minute to recovery ops.
Okay, so 1 minute to recovery ops.
Another question?
When do the CMIS bags deploy?
Exactly when, I'm not sure. It's a matter of about 3 minutes or so after touchdown. I believe all the bags should be inflated and it would be coming upright within minutes. I'm not exactly sure of the time.
Seeing that the Apollo missions were so long ago, what kind of consideration aboard the Navy ships to accommodate the additional crew as well as the new technologies to support our space crew?
That's one of the most amazing things with these ships. They have full surgical capability on board, emergency operating. We took a couple folks on tours today. The captain did to show off these, and it really is pretty amazing what capability they have. That's designed to support the Marines and the warfighter, but that's one of the reasons why we chose these ships. They have a 3D air search radar to help us track the vehicle when it's landing. Have great communication capability to communicate back to higher headquarters and keep everybody informed. We have a flight deck and a hangar capability so we can have our helicopters on board to provide support and the maintenance to support. And then the medical capability is truly amazing. The ship on the left is an LHD. That's one of the ships that Jim was talking about. A lot of times when they pull into port, they're the largest hospital in that country, that port. So that capability to provide support to our Marines. So and the medical capability, not quite the size of the number of beds in the hospital, but the LPD, the new LPD rivals that. Okay, so it looks like they have the BTA lined up, which is connected. So now, now it's a Navy operation, really, when we start connecting the lines. Our Det 3 role, we're a liaison. Jim's team is advising and making comments to the Navy crew, but it's a Navy-run operation. This is what they do. This is what they're trained to do, is to pull things into their well deck if they need to, based on that emergency LCAC recovery procedures. So when we talk to the bosun on board the ship, the ship's bosun is the most experienced amphibious sailor and well deck ops on the ship, and he's running the show now. He's talking to his guys that are the line handlers. He's talking to his guy that's talking to the NASA winch operator, telling him to winch it in or to slow it down. So it looks like now we got it in position, and the Navy Zodiac should be moving in to be handed tending lines, and they'll maneuver in, and they'll be connecting the tending lines to the 120 and 240 attach points on the back, the same position where we have the lines from the two Navy ribs. This is probably one of the most hazardous parts of the operation for our team. It's nice and smooth now, but when you're out at sea, you see some waves and some, a little rough seas here. So we anticipate a little bit more challenging, but it's not things that they don't do already. Okay, so they've got the tending lines. They're bringing them out. There are two tending lines on each side, and then the liners will be having those. They have them actually one loop wrapped around a T-bit on top. There's several T-bits all along that use them to do the line handling. That takes a lot of the control, so they're not getting tugged back and forth. You have a fixed with a line around it, standard Navy ops for line handling.
How big is this thing compared to the Apollo? A lot bigger?
We're about 20 as Apollo. Apollo is about 10 feet tall, 12 feet wide. We're 12 and a half feet tall, 16 feet wide, or in diameter. You could put Apollo in the pressure module on this. So we're significantly larger and nearly weigh twice as much. I mean, that's why we're doing this type of recovery. Okay, it's still lined up. We're still in the pause. Divers are going to be attaching the wing wall tending lines, and then they're going to clear out of the, and so we'll have tending lines to tend it from the small boats and the wing walls. The wing walls will not take control until it crosses this sill, which is the point where the stern gate and the bottom of the well deck connect. And that's where we have about a point to those T-bits, and that's where they'll start taking control and be able to control PA. So you'll see them being taken. Once they are set up, then we'll restart the winching operation, pulling it in through the fair lead, pulling it into the recovery cradle. Once the wing wall tending lines have control, the divers will be able to come in and disconnect the lines from the small boats. And that's the point where Jim talked about, and where normally the stern gate would be raised to a 45-degree point. So if you think about, if you closed it up all the way, it'd be like your bathtub. If you splash in your bathtub, the waves all start getting crazy. That's what would happen in the well deck. So if they put it at 5, those waves can hit and they can splash out, and it kind of calms the waves down inside the well deck. There's also some attenuation systems forward at the ramp where it can help attenuate the waves created in the well deck. Looks like they're bringing it in over the sill. So they've transitioned over that stern gate. So like I said, the next step is the divers in the Zodiacs will go in and disconnect the lines from the seven. All of the orange lines we're using are actually floating lines. So if for some reason one of them did get loose or something, we really don't have a concern about that with the ship going through the water. Obviously, we want to maintain control of them. Like I said before, with this stationary test, sometimes we have a tendency, the winch is a lot stronger than the people, so we have a tendency, we pull it in, you know, and we can get it seated before really we've gone through all our procedures and disconnecting the lines. So, in underway ops, that's not going to happen. That's not going to be a concern because it's going to naturally want to stay back. So the next step would be to disconnect those tending lines, and then what we would normally do, it's clear of the stern gate, they stern gate to 45 degrees. If the seas are rough, the well deck, they'll let them calm down a little bit, and then they'll bring it into our cradle. Has some bumpers, and then that fairly gets it lined up perfect, and then they can start deballasting the ship and pump the well deck. Any questions on anything?
I'm Ben Dalton from TV Tokyo. What is the material that the boilerplate is or what is used to construct the boilerplate?
It's made of steel and aluminum.
Okay.
And I think, like Scott said, this one was actually built to do Langley drop tests, to look at over at Langley where they were dropping to their basin, and they're graduating to a technically correct vehicle closer to the true makeup of the vehicle, and they were able to provide this to us for all of our Navy training and testing.
Is the weight comparable? Is it roughly the same?
Yeah, both the weight and the center of gravity are comparable to it, because we wanted to be able to you'll actually notice, well, you can't see now, but the vehicle actually has a bit of an angle, which is the center of gravity is a little bit off center on it purposely, because that's the way the flight vehicle is. So it's very high fidelity in terms of the weight and CG. Andy mentioned the Langley testing. One of the other things we've used articles like this for at Langley Research Center is a water drop facility that you may or may not have seen on your this week. We actually dropped the vehicle in at various angles to understand the impact, how the impact with the water when you're under those parachutes or different parachute conditions impacts the vehicle. And then we use that information to go back and inform the design of the flight vehicle. So as Andy mentioned, this was the first article we used. We've got another article I talked about that will be reconfigured also to go to Langley for similar testing. So
what's your assessment? Did this pretty much go the way you wanted?
yeah, terrific. I'd leave it to Jim and Andy to comment on it too, but this was exactly what we wanted to do. We don't like surprises. That's a bad test. This went exactly as we had planned, so I think it's a good test. I think Jim may have mentioned it earlier, but we have a series of primary test objectives and secondary test objectives, and as of yesterday, completed all of our primary objectives once and most of our secondary objectives, and as of the end of this test, we've now completed, I believe, all of those objectives. So in the time for our testing, the remainder of today, we'll probably continue to try to do repeated recoveries, but for the most part, we've got the data we needed, and I think this is a very successful week of testing. So.
And are these teams, are they working on their own, or are they getting radio communications to instruct them, back them up?
Yeah, great question. There's constant radio communications going on both between the ship and the dive teams and the boats, as internally, and you'll probably see it if you go on the ship later. There's a well deck control area that overlooks the well deck, where the operations within the deck are being controlled, as well as the rope handlers or the line handlers up on the wing walls as well. So, Andy, you know that better than I do. So.
Actually, we're using all of the same Navy communication setups that they would use to do their own operations. Well deck control, topside ops. The windows on the right side are debark control, where the ship's first lieutenant would be. He would be controlling the boats, and then as they are getting ready to come into the well, doing that dance behind the ship, that's when the ship's bosun takes over. He controls the line handlers, the winch operator, and he boats and telling them what he wants to be done. And then we also have one of Jim's guys, Mike Generali, is in well deck control. He has our NASA checklist that we've worked through and developed with the Navy, and he's making sure we're hitting all our steps and all our items going through that checklist. And well deck control is really kind of the central nervous system. That's where they actually ballast and deballast the ship. They control the stern gate, and they have full comms with the captain of the ship up on the bridge.
Last question. During the Apollo era, did we have any kind of a ship like this?
Well, you say like this. I mean, did we have a well deck ship capability? I believe we did. Yes. We did amphibious landings, obviously during World War II, during the war. It's not like this. It's not like the ships we have today. We have a lot more capability today in our Navy.
Okay, with that, that concludes our formal program. I know we do have time for some one-on-one interviews if folks are interested in talking to our NASA and Jim or Commander Moyes. And I'd like again to thank everyone for coming.